I am Chandan Saw. As you can see my ID card in dual mode video, I am currently in foundation level of BS in electronic system, and this is my experiment 4 demonstration video, and we are going to understand the VI characteristics of a normal diode, that is 1N4007, and Zener diode 3.6 volt with hands-on experiments. And we are also going to apply the knowledge that we will be gained, and to apply this knowledge to design a half-wave rectifier circuit and even analyzing the circuit. We are going to part 1, and this is the circuit, and these are the materials we are required. And part 1 and part 4 are similar, so we are going to both in a go. This is channel A and ground is connected here, and diode is connected with a series of 1 kilo ohm resistance, and we are passing now 0.1 volt through the circuit, and we are measuring the voltage drop across the resistor. This is millivolt, will be millivolt, so we are put in the millivolt, and this is 0.1. Now we are going to change the now at 1 volt 440 around, that is here we noted earlier, and this is the graph of the VI characteristics of diode, and this is the data ID, and we used the calculate ID dividing by 977, that is the approximate value of resistance that we measured using the multimeter, and this is the graph plotted. You can see reverse bias just opposite ground and VCC. Now the data of reverse bias is also plotted. The reverse saturation current is nearly 1 microns. Now we are moving to the second part, that is 4 part. Zener diode 3.6 volt and VCC and ground is connected, and now we are measuring 260, that is 1 volt at 1 volt, that is 260 volt voltage drop across the resistance, and that is 220 resistance. And for reverse bias we just put first ground and then after the VCC, and now we are passing 2 volt, and the drop we measured around 5, that is minus 5.6 earlier we noted. And this is the graph of the VI characteristics of Zener diode, and this is forward bias region, and this is backward bias, reverse bias. And now 2 volt minus 5.6, that is now DC 2.5 and at 50 hertz. Now we can do it with using a sine wave of passing 0 to 2.5 volt, and the lifting will be happen now. Okay, and now comparison over, and now part 2 and 3 we are using this circuit, a load resistance of 10 kilo ohm, that is diode and resistance, and resistance value is 9.89, the VCC and ground, and this is channel B for the output, channel A and 2.5 volt, and this no, not using ground. And this is the sine wave we are passing 0 to 2.5, and now we not need to sweeping, just need we are using the sine wave to normally increasing to see the graph what is happening. This is the rectified half sine wave, that is rectified sine wave, rectified DC voltage, and now this is the current output you can see. And now we are moving to this part of, but we are introduced the capacitor. Now we introduce 104 capacitor, that is 0.1 microfarad, and we are passing at a same frequency 50 hertz, sine wave same. Now the minimal changes, nothing will happen, and this is the LED, and we used the circuit to draw, and now this is blinking at 50 hertz, you can see, In the pattern you can see this is at 50 hertz of the same frequency. You can see the output current waveform, and this is the output current waveform minus 0.5 something. Now for part 3 we have to go to 1 hertz. Now we are going to pass sine wave at 1 hertz frequency. Now you can see the pattern. This is slow at 1 hertz frequency. You can see the output waveform and input waveform as well. This is the input waveform 0 to 0.1 around, and this is the output 0 to minus 0.1 around. You can see. Now we introduce a capacitor. Now we are going to run again at the same frequency and same. You can see the minimum change will happen, and now you can see the pattern mirror is likely same. Now you can see slightly change. Now we are going to compare the input waveform, rectified waveform and all, and the rectification efficiency and power, the ripple factor we are going to calculate. That is BDC, V average of the input, V peak by pi and 2.5 by pi, and VRMS will be V peak by 2 because of sine wave. That is 2.5 by 2, that is 1.25. Now we are going to ripple factor, VRMS by VDC ka whole square minus 1 we calculated using this formula of the ripple factor, that is 1.12, that is 1.21. rectification efficiency that we calculated using this data, that is 40.55%, and the above is calculated value, and but measured VRMS is 1.38 and VDC is 0.83 volt, and the ripple factor this time is calculated value 1.32, and that is rectification efficiency that comes nearly 36.2%. You can see ripple factor and rectification efficiency we calculated. Now going to move to compare the input and output waveform. This is the voltage and the current waveform, and the half wave rectification here happen in the voltage that you can see. Now we are going to see the current. Then since we are using the 2.5 volt DC offset is using place of grounding, that's why mirroring happens the input current waveform.